Hello, computer. Okay, this is exercise 10F1, question 5. Nice little application of a geometric series. So basically this person's getting $2,000 once a year, but every year they're not only earning interest, they're also getting an extra 2,000 added. So the book says, well, the first year you just get your $2,000 at the end of the year. This A standing for amount 1 after 1 year. After the second year, that $2,000 earned interest. So this 1.06 is a multiplier. It's made up of 100%, that's the 1, and the 6% interest. Then at the end of that year, they're also getting $2,000 added. Right. Now, I want to write it out slightly differently. So I'm going to do that. Because if I write it out differently, it will become apparent that this fits the pattern of a geometric series. So this $2,000, when we get to year 2, has earned interest. We've kept the 2,000 times it by 1 and we've added 6%. We also add in 2,000. So instead of just writing amount 1 times 1.06, I'm writing the 2,000. Then after the third year, okay, this new number, right, after the second year it was multiplied by 1.06. After the third year that would have happened twice. So this one is dropping down here, right? It's getting that interest again. This one is now had time to earn interest, and you've added on it an extra 2,000 for that year. When you get to year 4, right? This original 2,000 had 1 year of interest, 2 years of interest, 3 years of interest. Then this 2,000 that came in the second year, 1 year of interest, 2 years of interest. All right, this 2,000 has now earned interest. And there's a new 2,000. At this point, hopefully, you can see, I'll change color panda. This is like T1. This is T1 times R to the 1. Maybe we could think of this as R to the 0 actually. This is T1 times R squared. And this is T1 times R cubed. And if we want to know the total amount, we have to add those all up, right? So given that our geometric sequence formula, let's write geom sequence, general term formula looks like this, n minus 1. You can see, right, there you go, there's T1. If I make n equals 1, there's 2, there's 3, there's 4, right, using this T1 times R to the n minus 1 formula. We're adding it up, right? So therefore, we can think of calculating these amounts using a geometric series formula, Sn. The formula looks like this. We've derived it in class. Right. If you've forgotten, go online. There's plenty of people deriving it online, and your book does it as well. So we could just plug in the numbers. Term 1's 2,000. Now in the book they ask you for 10 years. If you go back to the question, when it gets to the end here, find the total bank balance after 10 years, right? I won't do the other parts. I just want to point out why this is a geometric series. So the R value, or the multiplier is the word we use in financial maths, is 1.06. 10 for 10 years minus 1, and you can just plug this into the calculator. You're going to have R minus 1, so 1.06 minus 1 is 0.06. This part's going to raise this number up to get to the total, and I've put this in the calculator already here. All right, 2000, right, there's my R to the n minus 1, that's my divide by R minus 1, and I got 26,361 and 59 cents after 10 years.